So we were discussing the zero order, first order, and second order. Uh, Zero order is all the single constructs are known as zero order constructs. Like in this case, the perceived work quality is measured by 6 items. So all the 6 items are just representing the construct, and we call it a zero order construct. And in this case, how many zero order construct we are having? If I ask you, then how many zero order construct we are having? Answer is 5. There are 5 zero order construct in this model. So when we are having 2 or more than 2 zero order construct in a model, this is known as first order model. This is called first order. So I repeat, when we have the 2 or more than 2 zero order, then the model is known as the first order model, right? Each single construct is a zero order, but when we have more than 2 zero order construct in the model, it is called first order model. So this is the difference between zero order and the first order. I hope it is clear. So this single construct is a zero order, and the set of 2 or more than 2 zero order, that is called first order. And in this case, if you see this diagram clearly, these are retention strategies. And this construct is consisting of 1, 2, 3, 4, 5, 6, 7 different construct. So one construct consists of other construct. In a second order, if the construct is represented by other construct, then it is known as second order construct, right? So let me explain in the diagram. So this is my zero order construct. And this is my second order construct. This is 0 and this is second order. So single construct is always either the zero order or the second order. In zero order, the construct is directly measured by the items, and second order, it is always measured with the help of other construct. So second order construct consisting of other construct, and zero order consists of only item. So this is the basic difference between zero order and the second order. And what is first order? When you have more than 2 or more than 2 zero order, and they have relationship between them, is called first order. So in this way, we explain the difference between zero order and first order and second order. So let me repeat once again. Just want to show you that. So what is a zero order? Simple construct with item zero order. 2 or more than 2 construct in a model, this is called first order model. Then if we have construct represented by the other construct, then it is called the second order construct. So I hope now you have clarity between the zero order, first order, and the second order. Okay. So one of the question is coming in the chat box is that whether the second order is formative. The second order is formative as well as reflective. Like for example, the service quality. Service quality is a second order construct. It is represented by tangibility, responsiveness, assurance, reliability, right? Responsiveness. So it is known as reflective second order. But financial literacy is also a second order, and it consisting of financial knowledge, financial behavior, and financial attitude. So it is a second order formative construct. So we both have the second order formative construct and second order reflective construct. And actually there are 4 types. So let me explain you that also. So there are four types. We are talking about the second order only, like uh, reflective, formative, reflective, reflective, formative, formative, and formative, reflective. So there are four type of second order construct. Let me explain you that one by one. Suppose this is a second order construct, and let me draw the diagram like this. Okay. So can you tell me which kind of construct it is? It is a reflective formative, formative reflective. What kind of construct it is? So this is reflective formative. Very good. This is actually the first is first. This is first layer, and this is second layer. So this is reflective formative. Similarly, if I ask you, uh, so we have this also, like this. So in this case, we have formative at zero order and reflective at second order. So this construct is known as formative reflective. So this construct is known as formative reflective. Similarly, if I put arrow here side, this is called formative formative, formative formative. So in this way, we are having different kinds of second order constructs. And this knowledge is required because when we study the research papers, we should know which kind of construct we are going to use. So I hope now we are having clarity on the type of construct. Then the next concept which we should understand is exogenous, endogenous, mediating, moderating. What is the concept? So the answer is very simple. Whenever you find out the cause and effect relationship, like X causing Y, so dependent variable is called endogenous, independent is known as exogenous, and the construct which comes in between exogenous and endogenous is called mediating. And if the relationship between X and Y is changing because of other construct, it is called moderating. So this concept, I know that most of the people have confusion. So let me explain. Suppose I have X to Y to Z, right? All these are construct. So this is called exo. This is called endo. This is called mediating. Mediating. So we are having the exogenous, mediating, and endogenous. Like for example, I'm giving one example. The customer attitude is having the impact of purchase intention, and purchase intention is leading to purchase behavior. So purchase behavior is the outcome variable, dependent variable. We call it endo. This is mediating, and this is called independent or exo. This is one. So there is no confusion between the exogenous. So by looking at the diagram, you can tell that which variable is independent. You can also tell me that which is mediating, because anything which comes in between is called mediating, and anything which comes in the end, so it is endogenous. Now the confusion comes, what is moderating? So let me explain moderating. So we say that X is influencing Y, right? For example, social norms in influencing the intention to adoption. For example, nowadays, you know that smart watches is a new product which is gaining very popularity. And now the question is that why people are adopting the smartwatch? And one of the answer is that whenever you see somebody else is wearing the smartwatch, you have a tendency to buy. So social norms. So what is going on in the society? is also causing the adoption behavior, right? Now my question is, do you think the adoption behavior because of the social norms is different for male and female? If yes, then gender is a moderating variable. Why is a moderating variable? Because the impact of social norms on the adoption is different for male and different for female. Similarly, it may be different for age also. Similarly, it may be different for income also. So in this way, we want to check whether the impact of X on Y is different for different categories or not. If yes, it is called moderating variables. This is called moderating variable. And because these variables are categorical, so this kind of moderation is known as categorical moderation. So we call it categorical moderation. So what is categorical moderation? If a nominal variable changes the relationship between X and Y, is called the categorical moderation. Now in another case, so let me delete this. So this is adoption. Now I have a variable called trust. Like because in one of the cases I can explain. Cryptocurrency, everybody heard, and everybody was investing in them, right? In last 2 years, I have seen that many Indian start investing in cryptocurrency. So cryptocurrency, because of the social norms, everybody was investing. So you started also investing. So because of the social norms, you are investing. Adoption means investing is also adoption. So because of the social norms, the people are investing in cryptocurrency. But I found that there is a factor trust which comes in between. So if you have trust on the technology, you have a tendency to invest. If you don't have trust on cryptocurrency, you'd never invest. I know many people who say that I don't have any trust on cryptocurrency, so I don't invest. But other people say that because everybody is investing and I believe in technology, I invest. So this relationship is also influenced by a variable trust. Trust is not a category. So normally we put moderating variable in parallel to find out that how this trust is changing the relationship between X and Y. So what we do, we multiply X into trust and we join this also. This effect, which effect? This effect, this line is called moderating effect. So we want if trust increases, whether this is also increases. When trust decreases, whether it decreases. So when you want to see whether the relationship between two variables is changing because of third variable, is called moderating variable. And to explain, I am giving you a very simple example. Let's say food intake and weight gain, right? So if I ask you how much food you eat, how much weight is increasing, do you think it changes with age or exercise? Answer is yes. Anybody who is doing more exercise, weight gain will not there. Even you eat more food, weight gain will not there if you do exercise. And if somebody is not doing any exercise, then food intake is having more impact on the weight gain. So a level of exercise is also changing the relationship between X and Y. So it means exercise is playing a moderating effect between X and Y. So we have to understand the theoretical relationship between the construct. So whether it is a moderating, and we have some more complicated relationship like moderated mediation, mediated moderations. So we will learn these techniques in much more detail. So the point which I want to discuss here, there is a different kind of behavior of the variable. Different kind of behavior of the variable. So some variable are dependent, some are independent, some are mediating, some are moderating. So if you write a paper, you must understand the relationship between them. So because in the paper, all these things come from the theory. So we must understand that which is the dependent variable, which is independent, which is mediating, which is moderating. And you can also combine mediation and moderation. So by combining the complicated relationship, I believe that you can write better papers. So because PLS is a theory test model testing exercise. So all these models are explaining the relationship between different variables. And you know that there are different type of relationship. For example, in this case, in this graph, and I hope you are not of reading, having fear from this graph. All the variables here are endogenous, exogenous. So 1, 2, 3, 4, 5. These are 5 exogenous. This comes in between mediating. This is endogenous. And this green is representing the moderating effect. So by looking at the diagram, we can tell that which is dependent, which is mediating, which is independent. So you must understand the basic concepts that how we can identify mediating, moderating, and exogenous. So I hope you are clear on that now. Similarly, in this diagram, this is dependent. There are two mediations. So there are two mediating constructs in this. Two constructs come in between exogenous and endogenous. So we are having this kind of model also. And this is second order exogenous construct. So now I think the concept is clear. So we have explained 4 things, and we have to explain all these relationship in much detail. We have a separate lecture on the mediation itself, separate lecture on the moderation itself. So there I will explain you in much detail. So only thing today we have to learn is that how to recognize by looking at the graph or diagram that which is dependent, which is independent, which is mediation, and like that. So if you see in this graph, if I ask you that which constructs are mediating construct, you can tell very easily that turnover intention is coming between retention and organization performance. Employee turnover is also coming between these two. So there are two constructs which comes in between, independent and dependent. So there are two mediating construct in this diagram. Organization performance is dependent and retention strategies are independent. So this is, in this way you can tell me which is dependent, independent, mediating, like this. Okay. Now we are moving to the next part, that is called the measurement model and the structural model. We have used these words frequently in the SEM terminology. There are two different type of model. One is the measurement and second is the structure. In simple language, measurement model is the questionnaire. A structural model is a hypothesis testing. In simple language, we can define like that. So what is a measurement model? Measurement model is a questionnaire. What is questionnaire? Questionnaire is a combination of construct and their items. So whatever scale you are using in the questionnaire, so that scale is called measurement model. In measurement model, we want to prove that the questionnaire is valid, reliable, bias-free. So we have to explain many things. Because whenever you take the data from the questionnaire, it is your responsibility to prove that your questionnaire is bias-free, it's reliable, it's valid. So that is called examining the measurement model. So these stages are known as examining the measurement model. In MOS software, the measurement model is looking like this. But we are not having any kind of diagram in PLS software. So in PLS software, the advantage is that the same diagram you can run as a measurement model. The same diagram you can run as a structural model. So this is the benefit we are having in PLS diagram, because in MOS, you have to make measurement diagram separately. You have to make a structural diagram separately. So this is called measurement model. This is called a structural model. This is also a measurement model. So we are confused that which is measurement model, which is structural model. But in smart PLS, the same diagram. Only thing is that you have to give different command for measurement model, different command for structural model, but model is same. So there is no differentiation between the measurement model and the structural model according to the image, according to the graph. The graph is same. Only thing is that the commands are different. Different commands we use for measurement model, questionnaire, structural model, hypothesis. So remember always two things. What is measurement model? Testing of the questionnaire. What is structural model? Testing of the hypothesis. Simple. So when you want to prove the questionnaire is valid, reliable, bias free, then you have to run measurement model. When you want to run the hypothesis, you have to run a structural model. Like in this case, both the diagrams can be run both as a measurement model and structural model. The purpose of running measurement model is to check the quality of the questionnaire by testing reliability, validity, and there are many more things like multi-collinearity, construct loadings, some right. A structure model is only for hypothesis testing, whether there is a significant relationship between the construct or not. So this way we explain the measurement model and the structural model and how to run it. So we will discuss in coming lectures. So today is the day of basics. So try to learn the concept basics. So remember one thing, measurement model is for testing the quality of the questionnaire by testing reliability, validity, biasness, multi-collinearity, and the structural model is to check the hypothesis between the relationship for the relationship between the constructs. Now, inner model, outer model, I already explained to you. The lines between the construct, like these lines between the construct, represent inner model, and the line representing the items and the construct. So these lines. So you can see this dotted green line. So dotted green line is representing you the relationship between the construct and the item. So this is called outer model. So outer model is representing the relationship between the construct and the item, and inner model is representing the relationship between the constructs. And inner model we are having path coefficient. In outer model we are having the construct loading. So for example, I'm showing you this case. So these numbers, you can see these numbers between the construct, they are path coefficient, and these numbers, you can see these numbers, the number coming between the blue and the yellow, these numbers are known as construct loadings. Simple. Now there is one simple difference. You can see these numbers. So what are these numbers? These numbers are outer loadings. And what is these numbers? These numbers are path coefficients. So I explain here path coefficient. Now, suppose my construct is formative. Still, I can say it is a construct loading. Or if this construct is reflective, can I say path construct loadings? No. There is a nomenclature. If the construct is, so listen carefully. If the construct is a reflective construct, these numbers are known as outer loading. And if this construct is a formative construct, the numbers are known as outer weight. So we have two terms here, outer loading and outer weight. So what is outer loading? Outer loading means the number in a reflective construct. Outer weights means the number in a formative construct. Right? So we have two types of construct, you know that, reflective and formative. So in reflective, we call outer loading. And for a formative construct, we call outer weight. So these are the two terms we use in outer diagram, not inner diagram, outer diagram only. So in this case, in this example, can you tell me which numbers are outer loading and outer weight? So if I ask you, these numbers are outer loadings or outer weight? So just type in the chat box that what do you mean? What do you understand by these numbers? So these numbers are outer loadings or the outer weight? Okay, so all of you are saying outer weight because it is a formative construct, and the other numbers are outer loading because they are reflective construct. So for a reflective construct, we call outer loading, and for a formative construct, we call outer weight. So slowly and slowly, we are learning the terminologies. So all the answers are right. Now, my last slide concept for today is there are two types of SEM. So we are talking about the structural equation modeling. So there are two types of SEM. The one is called covariance based SEM, and second is called PLS based SEM. They are mathematical terms, so we do not require to understand the mathematics, but very simple thing I'm telling you. So you have heard about the matrix algebra, and you also know that the regression modeling. Covariance based SEM, covariance based SEM, covariance is following the matrix algebra to calculate the construct loading and the path coefficient. It is a different mathematical procedure, right? And in covariance based SEM, the concept is called maximum likelihood estimation method. So CB-SEM is based on maximum likelihood estimation method. So it is an entirely different method, applying the iterative process using matrix algebra. And the second type of SEM is based on regression modeling and not a maximum likelihood estimation, rather partial least square method. So the AMOS software, there is a software called AMOS. It is a software provided by the same company which offers you SPSS. So AMOS is a sister of SPSS. You can understand in this way. The parent is same parent, SPSS and AMOS. So they are brother and sister. And AMOS is working on covariance based technology. However, the smart PLS, which we are going to learn, is not adopting the covariance based technology. It is adopting the regression based technology. So because of this new different technology, we are having some advantage. Like, what is the basic advantage I'm telling you? The covariance based SEM don't handle formative construct. This is the biggest problem of covariance based SEM. So whenever you are having the formative construct, the AMOS will fail. It's not able to run the model even. But PLS-SEM is a very good software of utilizing the formative construct. So formative construct is one of the reasons that why you should choose PLS-SEM as compared to AMOS. Second thing is that second order constructs. Whenever you are using the second order construct, CB-SEM is not giving you good results. Sometimes we are getting path coefficient more than one, right? Negative variances. So CB-SEM is not very good in handling the complicated models, formative constructs, second order constructs. So when we have three cases, basically, number one, when you are having the formative construct, number two, when you are having the number of construct more than 5, or third, when you are having second order construct, then PLS-SEM is much better as compared to CB-SEM. Another part, there are two more differences. Number one, sample size and distribution. If your data is normally distributed, CB-SEM is applicable. If your data is not normally distributed, PLS-SEM is applicable. So sample size is one of the reason. Distribution. So normal distribution, CB-SEM. No normal distribution, smart PLS. This is another reason of choosing the smart PLS, because you say that data is not normally distributed. The last reason of using the PLS-SEM is that PLS-SEM is even good for a small sample size. Even if your sample size is 100, PLS-SEM gives you best results. But CB-SEM, covariance based SEM, require large sample size, 10 times more than the number of variables. If you have 30 items, 300 sample size is required. So large sample size is required in MOS. In PLS, even if the sample size is less, you can run it. So yeah, we are explaining the difference here. So all the explanation is mentioned here. Don't need to remember that CB-SEM can be run by these softwares. PLS is run by Smart PLS. Distribution, multivariate normality distribution is required. Here it is no distribution. Sample size, large sample size is required to run CB-SEM. A small sample size in enough in PLS, like this. So only reflective and formative. You can use only CB-SEM only when you have interval variables. If you have categorical, you can run PLS also. So these are the differences. These are the diagrams which are based on MOS software. All the diagrams are known as covariance based SEM, and all the diagrams where you can see blue and yellow, they are called PLS based SEM. So this kind of modeling we can do in Smart PLS, and this kind of modeling we can do in MOS. So there is a separate workshop for MOS, but in this workshop we only discuss Smart PLS. So this is the difference. So here I mentioned what are the different reasons of using CB-SEM and why you should go for PLS-SEM. So the reason of using PLS-SEM is non-normal data, small sample size, formative constructs, complicated models, categorical variables, and research objective prediction. So when you want to predict the model. And reason for using CB-SEM, large sample size, normal distribution, only reflective measures, theory testing approach, hypothesis testing, scale variables, only scale variable you have, and you are more focused on the testing relationship between construct. So this is the basic difference of using PLS-SEM and CB-SEM. So, okay. So now it is the last slide. Yeah. So how we can take the construct? So construct is coming from the literature. Most of the time, the construct is coming from the literature review. You go to the content validity. Construct loading, you have to check for each construct, that we will see how we can check it. And if the variable, if the statement is having construct loading less than 0.5, we have to drop it. And then we have to check CFA of all the construct. So these things we will do in development of a model. So now I am going to the practical part and demonstrating you the software. So theoretical part is over. Today is the first day, so more theory is there. And so whenever you want to open PLS software, this is the icon. If you double click on the icon, this page will open. So now we have to spend 10 to 15 minutes with this only, with the software. So when you open the blank page, this is the blank page, right? Now step by step. First of all, step number 1, go to new project. Now in the new project, I am typing here exercise 1. So I am putting 0, 0 because I want to see this in the top. So 0, 0 exercise 1. This is the name of the project, and it comes here on the top. Actually, I have a long list, so that's why I want it on the top. So exercise 1, 0, 0. Now this kind of view you can see first time. There are two options here. Double click on the import data and exercise 1 model. So once you create the project, the next option is to import the data. So what is the first step? Give the name of the project. After clicking the new project, after that, double click here and you need to import the data. Now, what is the rule of importing? So this you should understand. The basic rule of the data is the data should be in the format of CSV, comma separated values. It is a kind of Excel file. So whenever you have the data, you have to convert the data in CSV format. It is compulsory rule of the PLS. So whenever, if I click on this, I have to tell, so where is my data? So I have to find out the data set. So I have a folder, data set. All the data set are provided to you. And this is my exercise 1, PWQ. So I click on this data, and this data, you can see it is a CSV format file. If I click on this, you can see comma separated values file. So it is a CSV file. So I double click on it. This is the name of the data. Okay. Now you can see this is green now. Green means the data is successfully imported. What is the name of the file? Exercise 1, perceived work quality. And 358 are the records. So how many observations are there in the file? 358. Now, whenever you run first time, you can see the missing values. If any variable is having a missing values, what is the mean of the observation? Mean, median, minimum, maximum, standard deviation, skewness, and kurtosis. All numbers are coming automatically. The only thing you have to check is that is there any skewness and kurtosis more than 1? No. So in this data, we don't have any skewness or kurtosis more than 1. I think because this is very important, why you have to show that my data is normal. And mean, median, minimum, maximum, you have to report in the thesis, so you can take the values directly from here. Okay. Now after that, go to the exercise. This is the name of the model. So when you double click on it, a blank page will come like this. So it is a blank page. And in this blank page, it is called canvas. We can make the diagram on this canvas. So I'm showing you how to make the diagram. So to make the diagram, what you need to do, in the lower part of the right hand side, you are having the indicator option. So you can see we are having the indicator option. Now select this FI. So this is my first construct, right? FI means financial incentive. So I drag and drop here. Very simple. And I want to rename it financial incentives. So now in this way, I defined my construct. So let me tell you something. If you right click on it, you will have these options. If you click on align indicator top, they will go to the top. Similarly, left side, similarly bottom side, similarly right hand side. So like this. So we can change the shape like this. Number 1, we can use Alt W, Alt A, Alt S, Alt D for changing the direction of the arrows. Second thing, if you want, you can hide the indicator. Like for example, if sometimes the model is very big, so we need to hide the indicator. So you can hide it like this. And if you click on LC, the indicator will come again. So I'm putting on the left hand side because it is my independent variable. And so you have to just, if you want grid, so you can see, if you click on this, the grid will come like this, but I don't like grid, so I am removing it. And if you want to change the shape, like if you make it bold, it is bold. If you click on +1 in the here, you can see in the right hand side, we are having +1. So the font size will increase. And if I want to decrease it, I will reduce it. So we can manage the font size of each and everything by doing this option. And if you don't want this option, you just click on this icon. You can say there's a color box. If you click on it, it will go up. It will go. So you have an extra space to make the diagram. Now I creating another. This is CG. CG stands for career growth. So I'm renaming it career growth. It's my second construct. And if you feel the diagram is this space is not enough, you can click on minus. So if you click on minus, you can create extra space. So you can create a space by clicking on this minus. So it is very flexible. So now we are having the work culture, the third construct. So in this way, we can take all. I am renaming it. This is called work culture. And let me put it into the top so that I have more space like this. Then I have this IR, interpersonal relationship. So let it take here. And this is interpersonal relationship. And we can manage this also. Finally, I have another variable, last variable. This is the perceived work quality. So put it here. Shift to the right hand side. And let's rename it. This is perceived work quality. So this diagram I'm taking from the research scholar. One of the research scholar work on this model. The idea is to predict that what makes the good work quality perception. So after taking all these diagrams, so you can see the color of the construct is red. Red means the diagram is not complete. So we have to make it blue. So you can see that in all the slides we have seen, they are blue, not red. So red indicates the incompleteness and blue represent completeness. So I take this connect here. You can see I have an option connect. So you just connect the arrows between dependent and independent. And once the model is complete, it is all blue. So on the day one, you have to learn to develop the small models. So this exercise you have to repeat many times. Try to play with the data, try to play with the model. So in this exercise, you will learn so many things. So if you want to make any changes, go to select, right click, so you can select all these things. And after that, I will tell you one more thing. You can, if you go to the calculate, so we have a different options here, like PLS algorithm, bootstrap, blindfolding, CTA, IPMA, PLS predict, FIMIX, POS, MGA, permutation, and consistent. So in this workshop, we will cover more than 90% of the options. So we will cover each and everything. So you just try to run all these things. So just run PLS algorithm. So if you run it, you will get the result. It may be possible that in first day, you may not understand all the concepts, but slowly and slowly we will learn all. So today is just the day one, and I am introducing the basic concept as well as the software to you. So today you just need to do the practice by making this diagram. That's it. You just run bootstrap, you just run all other things without understanding the results. Just try to run each and everything. So the result will come in this format. This is the model. So this is enough for today. We have discussed what we planned to discuss today. Now I'm going to session for discussion. So we will discuss the problem here. Now I am stopping the recording. Why? Because most of the scholars say that, sir, we are asking our personal questions, so please don't record that.